is equal to area under the normal curve. Okay, so the other day, we said that alpha can be called critical value. The z value corresponding to alpha on the left is critical value to the left, and the z value corresponding to alpha on the right is critical value to the right. So z alpha over 2. Okay, so now let me calculate the critical value. I know that I can use my normal curve, or I can use a calculator. We do inverse norm. Okay, so anytime I want area to the left, I will do inverse norm, area to the left in decimal, and that is 0.03. Area to the left in decimal, the mean of a standard normal, which is 0, the standard deviation, which is 1. So I pull my calculator up. And when I clear, I have second distribution. So inverse norm is 3, so 0.03, and the mean is 0, standard deviation is 1. When I hit enter, I will have the value of z to the left. So the value of z to the left is the z corresponding to 0.03 is negative 1.88 or negative 1.88. I have negative 1.88. In other words, the critical value is z alpha over 2 is equal to plus or minus 1.88. Why? Because the normal curve is symmetrical. If I find the area to the left, I also know area to the right. Area to the right is the z value to the right is positive, the z value to the left is negative. Okay. All right, so that is the critical value for area on both sides. So what if I'm told to find area on one side? If I'm told to find area on one side, I will not divide alpha by 2. So let me see. Question 1b says find the critical value when alpha is 4%, 1/3 left. Find the critical value when alpha is 4%, 1/3 left. So I'm not going to divide alpha by 2 because it's a 1/3 test. Area to the left. So I'm just going to draw a normal curve, show area to the left, and that is 0.04. I am not dividing alpha by 2 because it's only 1/3 area to the left. Therefore, I will only find z alpha, not z alpha over 2. Okay, so what is the argument? The argument is inverse norm. And then the area to the left is 0.04. And the mean is 0, standard deviation is 1. I'll close parentheses and put it in my calculator and find the area to the left, 4% in the standard normal curve. Okay, so I'll find area to the left, 4%. So I'll go do again second distribution, inverse norm number 3. This time the area is 0.04. It's a standard normal curve, so mean is 0, standard deviation is 1. So I am going to paste. It's only area to the left this time. That's why I did not divide alpha by 2. So I have negative 1.75. So I will write z alpha. So my answer will be z alpha equal to negative 1.75. So Z alpha only, because I did not divide alpha by 2, is equal to negative 1.75, which means I'm not looking for Z value on the right. I'm not looking for Z value on the right, okay, because this is area to the left, 4%. All right, so let's go to the next one. So this is when it is normal distribution. What if it is not normal distribution? It could be a small sample, that is t-test. Find the critical value for the following. Remember, for t, I'm going to write the formula for t so we know. So for t, and let me pull this up. So the first question says find the critical value when it is a t-test. It is two-tailed and the sample size is 14. T-test uses degree of freedom. So just because this is one sample, I will have n minus 1 degrees of freedom. So remember, this is two-tailed, alpha is 2%. So I'm doing number 1C. Number 1C. Okay. And this is t-test. Area on both sides is equal to 2%. So I have alpha is equal to 2%. Or I can write 0.02, 0.02. The sample size is 14. Therefore, degree of freedom is 14 minus 1. And 14 minus 1 is 13. So degree of freedom is 13. So now I want to draw a T curve, T distribution. It looks like a normal distribution. Area under T distribution is 1. Remember the conditions. Sample size must be less than 30. Population standard deviation is unknown. And sample must be from a normal distribution. Sample must be from a normal distribution. So this is a simple random sample. So these are the conditions for T distribution. Okay, so I am told to find two-tailed, but I'm doing two-tailed also, even though it's T. So 100 minus 2, 100% minus 2% is 98%. And I can change it to decimal. So if I change it to decimal, I have 0.98. All right, so the central number is 0.98. And then I divide 2% by 2, I have 1% on each side. So this is 1%, 0.01, and this is 1%, 0.01. Now I'm looking for T alpha over 2. Remember, it is T, so you're looking for T alpha over 2, not Z. So I am going to find T alpha over 2 because it's divided by 2. Okay. So for me to find T alpha over 2, the argument is going to be inverse T. Inverse T. And then I'm going to write area to the left in decimal, which is 0.01 this time. The area, then the next thing is going to be then the next thing is going to be degree of freedom. 13. So I have 13. All right, so I will go to my calculator. So before we go to our calculator, I can just go, let me go and let's just make sure we review our t distribution. That way we have everything. So let's go to properties. It's the same property. And the area in the tails of t distribution is a little greater, it's a little larger. As sample size n increases, the density curve for t is almost equal to density curve for z. So these properties are here. And then, so let's go to t distribution. So if I, the notation z alpha is for z, normal distribution. T alpha is for t, okay? Similarly, we let T alpha represent T value whose the T distribution to the right is that. Okay, so that is the relationship. They all have area under the normal curve is 1. All right, so you can also be told to find inverse T. So if you are given, let me get to where they have, so you can be told to find inverse T using your calculator, doing it by hand. Okay, so you will, all right, so what I'm going to do now is get to my calculator and finish up finding the inverse T. Remember, we use degree of freedom. So I am going to use degree of freedom here. So inverse T, and then let me go to second distribution. Inverse T is number 4, and area to the left is 0.01. And the only thing they ask me is degree of freedom. And degree of freedom is 13. That's all I need. I just need sample size and area to the left. And then I can calculate. So the T value to the left is negative 2.65, and T value to the right is 2.65. Therefore, I can write T alpha over 2, because it's two-tailed, is equal to plus or minus 2.65, plus or minus 2.65. That is the value of T here is, the value of T here is positive 2.65. Okay, because it can be two-tailed also. So when T is two-tailed, you go back and divide alpha by 2. But notice that T uses degree of freedom. Z does not use degree of freedom. Normal curve does not use degree of freedom. So, all right, so the next question is another question on T. This one is two-tailed. Well, suppose I have alpha is equal to 2%, one-tailed left test. So this one is a one-tailed left. The sample size is 16, and it's only one tail, which also, in other words, I am not dividing alpha by 2. So I'm going to draw a T curve. Draw a T curve. The area inside the curve is 2% or 0.02. So I'll just draw that now. So area under the curve is 2%, one-tailed left. So I'm only looking for T alpha. If I'm given one-tailed left for T, I look for T alpha. Same thing for Z. One-tailed left for Z, I look for one tail. In other words, I'm looking for T value that corresponds to 0.02. Okay, I write the argument again. Inverse T. Inverse T area to the left in decimal 0.02, degree of freedom. I'm told that sample size is 16 in this question. Therefore, degree of freedom, DF, is 16 minus 1. 16 minus 1 is 15. Okay, so I just pull my calculator up. So it's that simple though. I pull my calculator up and then I find inverse T. So second distribution, inverse T is number 4. The area to the left is 0.022%. And the degree of freedom in this question is 16 minus 1, which is 15. If I paste, I will find that the t-value is negative 2.25. T-value is negative 2.25. So that is negative 2.25. That's the t-value. And it's only 1 because I don't have to divide alpha by 2. All right, so that is the question for this one. Let's look at question. Now, so we have answered question number 1. So let's go and answer question number 2. So for question number 2, it says, when should the t-test be used in statistical inference? When do I use t-test? In other words, another way of asking you, what are the conditions when you're doing inference? What are the conditions for using t-test? Conditions for t-test are sample size. Conditions for t-test are, I'm just going to write it here. Well, I can use this. Sample size must be less than 30. If sample size is greater than 30, it's now a big sample. I can use normal distribution. And population standard deviation is not known. It's unknown. Unknown population standard deviation. And sample must be from a simple random sample. In other words, it must be from a normal distribution. So these are the 3 conditions for using a t-distribution. When you don't know the population standard deviation and sample size is, in fact, even if one of them, if you don't know the population standard deviation, it's enough to use t-distribution. It doesn't really matter if sample size is greater than 30. If sample size is greater than 30, but population standard deviation is unknown, then you go ahead and use t-distribution. What are the conditions for using proportion? We said it the other day. We can say it again today. Proportions, conditions for proportion. 1, the variance, let's write that. Sample must be from a normal distribution. So sample from a normal distribution, all right? And then n times p times q must be greater than or equal to 10. And what does this mean? The variance. The variance of the binomial distribution must be greater than or equal to 10. You can actually use p hat and q hat if you don't know, because there's no way you can know population proportion. It's not always easy to know the population proportion. Okay. Now the next condition for using population proportion is that sample size must be less than 5% of population. Sample size must be less than 5% of the population. You can write it this way. N is less than 0.05 times population. All right, so whatever you're given a sample size, what you're going to do is you divide that sample size by population. And most of the time we use the population of America, which is approximately 360 million. And suppose you have a sample size of 200, and you divide it by 360 million. You already know that number, that number should be insignificant. So it is actually less than 5% of the population. And the third method or third condition is that sample must be from a simple random sample. In other words, sample must be from a normal distribution. The sample you have taken must be taken from a normal distribution. Remember, we have already written this. Let's write it again. In T, sample size less than 30. Population standard deviation is unknown. Sample from a normal distribution. Simple random sample or sample from a normal distribution. Okay, now let's go on and calculate. We already know, like yesterday we calculated, 2 days ago we calculated the confidence interval for proportion. We're going to do one before we get into confidence interval for T. Determine the point estimate of the population proportion. So this question here is on population proportion. All right. And the margin of error. So we already said that if I draw a number line and I know the upper bound of a confidence interval for proportion, so the upper bound is 0.285, the lower bound is 0.223. If I find the midpoint of this line, and midpoint of this line is adding the upper bound and lower bound and divided by 2. This is lower bound. This is upper bound. And then the p-hat, point estimate. When I'm told to find the point estimate, it's always p-hat is equal to upper bound 2.285 plus lower bound 0.223, and then I divide them by 2, divided by 2. Okay, so I pull my calculator up and add them together, divide by 2. Then I get the sample proportion. So that's what I'm going to do right now. Add upper bound and lower bound. 0.223 plus 0.285. And I have that, then divided by 2. When I divide it by 2, I get the point estimate. And the point estimate is the estimate of proportion. So the point estimate is 0.254. 0.254. And then they can ask me to find the margin of error. They did actually find the margin of error. The margin of error is the distance between point estimate and the upper bound. P-hat is the midpoint of the line. Then I can find the point estimate to the left, the margin of error to the left. So the margin of error to the right is 285 minus 254. So let me do that. So the margin of error is 285.285 minus 0.254. And when I get an answer, it is 0.031. Therefore, margin of error is 0.031. 0.031. And by the way, because margin of error is on the left, is on the right, I can now say margin equal to plus or minus So let me actually get my whiteboard because this is not responding. So that margin of error, ME, is equal to plus or minus 0.031. Another way of writing this is that I already know the point estimate. So if I'm given the confidence interval, I can now say that, suppose I'm given a 90% confidence interval. And by the way, if I'm given a 90% confidence interval, I can say that the population proportion is equal to sample proportion plus or minus margin of error. And then I'll quickly find what the point estimate is. The point estimate is 254. So, and that is the same as 254 point, remember it is decimal, plus, because they are all probabilities, plus or minus 0.031. Therefore, the population proportion, I don't know where the population proportion is, but in under 90% confidence, I can find it between 0.254 plus or minus 0.31, 0.031. Okay, so the margin of error. Okay, I want to make sure I write the formula again for proportion. You don't have to use formula, you can use calculator, but it's always good to know the formula, so in case you're told to. So for proportion, in case you're told to plug in the what you know in that. So for proportion, the population proportion is equal to sample proportion, which is the same as the point estimate, plus or minus Z critical value, two-tailed, multiplied by square root of P hat times Q hat, success times failure over sample size. Okay, I want to make sure you know what part of this equation is called margin of error. This section is called margin of error. This section is called margin of error. Margin of error. You can actually call it ME. ME. All right, so remember what you're looking for. You're looking for the population proportion. So you say, suppose you're given confidence interval of 90% or 0.9, you can say, I am 90% confident that the population proportion could be found between the point estimate, sample proportion, plus or minus the margin of error. Okay, provided the conditions are met. The conditions are NPQ must be greater than 10, greater than or equal to 10, and sample size must be less than 5% of population, 0.05 times population. So these are the main conditions before you can convert from binomial to normal. And if you normal, then you can use do it again, and then we start doing T confidence interval. So we're going to get one question on P confidence interval. So we want to do number 4. Number 4 looks like a proportion confidence interval. Number 4, proportion confidence interval. All right. All right, so a survey found that 195 out of 250 randomly selected internet users have high-speed internet access at home. Construct a 90% confidence interval for the proportion of all internet users who have high-speed internet at home. Okay, so you want to know what you're given. you are given the sample size. Sample size is 250. You are given X, the number out of sample size, and that X is 195. And from X and N, you can find success. Probability of success is X over N, and that implies 195 over 250. Okay, so these are what I'm given. But does this condition satisfy the is it satisfied? Can I do my conversion from binomial to normal? In other words, is this sample size less than 5% of population? Let's say that the population we are comparing with is the whole Americans. So 250. So let's say 250 over 360 million, approximately. Well, I don't even need to calculate this. I know that the number is insignificant. So 250 divided by 360 million, that number should be an insignificant number. So it's actually less than 5% of the population. So condition number one is met, because that condition number one is that N must be equal to or less than 5% of the population. Condition number one is met. Two is N times P times greater than or equal to 10? Well, let's find that out. Is N times P times Q greater than or equal to 10? So N is 250 as given to us, and P is 195 over 50, 195 over 250, and P, this is P, and Q is 1 minus 5 over 250. Okay, I am going to get my calculator and get the so first of all, I want to know what 195 over 250, what is it? What is 195 over 250? I'll just calculate it here. So 195 divided by 250, and I have the probability of success is 0.78. Therefore, probability of failure is 1 minus 0.78. 1 minus 0.78. So now I have everything. All I need to do is multiply sample size multiplied by success, 0.78, multiplied by failure, 0.22. What I'm checking is that, is this solution greater than 10? Yes, that solution is greater than 10. So condition number 2 is satisfied. Therefore, I'm allowed to do inference. Inference means confidence interval hypothesis testing. So now I can do inference. The conditions for converting from binomial to normal are satisfied. I can do inference. So let me do that. I am going to quickly put up my whiteboard. Pull up a whiteboard. Where are you? All right. All right. So okay. It's not coming out. Okay. Now I want to now do the confidence interval. Remember, I can write it down. Let me write it down. The estimate of the population proportion is equal to sample proportion, which is 0.78. I already found it. 0.78 plus or minus the critical value for is the confidence interval is 90%. Therefore, area to the left is 5% or z.05, because 90% minus 100 minus 90% is 10. 10 divided by 2 tails is 0.05, so 5%. Then multiplied by square root of the standard deviation of, so I have 0.78, which is P, multiplied by 0.22 divided by sample size, which is 250. So actually, this is what I'm supposed to simplify. But I can just write this formula like this and go to my calculator and put it in. So now that I know everything, I put it in here. What I want to do is go to my calculator. Go to my calculator. So I'm going to start, test, and I am looking for one prop z test. We did it the other day. One prop z interval, one proportion z interval. The conditions are met. So I'm looking for one prop z interval. I'm doing proportion confidence interval, and the conditions for converting from binomial to normal are met. So it's asking me what is x. X is 195, number of people who showed up. And what is the sample size? It is 250. Sample size is 250 in this particular question. Confidence level is 0.9. So I can now calculate the confidence level. And then the confidence level is starting from negative, from 0.73691 to 0.82309. And the point estimate is 0.78. Okay, so we can explain that. I can just write it to two decimal places. So this is 0.74 to 0.82, 0.74 to 0.82. Well, now I can add them up and divide by 2 to get the point estimate. I already know the point estimate. The point estimate is 0.78. And I can be told to find the margin of error. The margin of error is the distance between the upper bound and lower bound. 82 minus 78 is 0.04. So the margin of error is 0.04. So I have calculated the confidence interval. I can now say that I am 90% confident that the population proportion lies between the lower bound 74% and the upper bound 82%. I am 90% confident that the population proportion lies between the lower bound, which is 74%, and the upper bound, 82%. And by the way, you cannot be more confident than the confidence level given to you. You can be confident than the confidence level given to you. In other words, if I'm given 100, I can say that the interval from 74 to 82 contains the population proportion. Okay, so that is an example, a real world example of population proportion. That's a real world example of population proportion. And so the next thing we want to do is calculate the sample size for proportion. Sample size or proportion, I could be told to calculate the sample size for proportion. So N is equal to PQ, and P hat is P hat. Sample proportion multiplied by population proportion, multiplied by the critical value squared. So this is the formula for calculating the sample size. And all sample size must be rounded up. All right, so I want to calculate the sample size with the question given to me in number 6. You want to estimate the proportion of adults who have a fear of snakes or phobia. So what is the proportion of adults who have the phobia of snakes? What sample size should be obtained if you want the estimate to be within 3 percentage points? So I am given 3 percentage points, okay, and confidence level of 95%. If I have confidence level of 95%, then the critical value will be 0.025. So I'm going to put everything. What should be obtained if you want the estimate to be? And so they didn't give me the value of P though. And the value, I will assume that P is equal to Q. So I will say P sample size is equal to 0.5 for P times 0.5 for Q. Okay, 0.5 for P times 0.5 for Q. So I have times 0.5 for Q, and inverse norm 0.025, and I have to square this quantity. I have to square that quantity. So I'll start from inverse norm to calculate. So I'll go to my calculator and calculate inverse norm 0.025. So go to second and calculate inverse norm 0.025, which is number 3, and the area to the left is 0.025. And then it is a standard normal curve, so I don't really, you don't have to change anything. I'll hit enter, and then I got to square it. So if I square this quantity, I have 3.84 and so on. Then I multiply by 0.5 times 0.5, multiply by 0.5, and multiply by 0.5 again. And when I get my answer, the answer must be rounded up to an integer. Every sample size must be rounded up to an integer. So the sample size is 1. The sample size is 1. I have to round that up, and the sample size is 1. So n is equal to 1. Okay, find the t-value that, number 7, find the t-value such that the area in the right tail is that. So this is still t-value. And then so that next class we shall be doing confidence interval for t. Okay, so confidence interval, I'm not looking for confidence interval right now. I'm looking for critical value. So find the t-value such that the area to the right is 0.025. I can find area to the left and then change sign. That's what I'm going to do. So all I'm going to do now is inverse t, area to the left in decimal, and that is 0.025. And then the degree of freedom is given to me as 14. I will not change this one because actually they did not give me sample size. They gave me degree of freedom. So I have to be very careful. And so I'm going to put my calculator up and I'll clear. I'll go to second distribution and I look for inverse t, which is number 4. Area to the left in decimal is 0.025. And I am going to write the degree of freedom given to me. They have already converted it to degree of freedom. Because this is area to the right, so my critical value must be changed to positive because it is 0.025 on the right. Therefore, that critical value is 2.14. So the critical value T alpha is 2.14 because it is to the right. To the right. So the T value to the right is that. T value to the right is that. All right. So let me see if there's any question. Let's see. Do you have any question, Marty? Okay, do you understand? You follow, right? Very good. Very good. Okay. Okay. So the next one now is I'm going to turn this off and then start it.